A projectile is fired at an angle of inclination alpha with 0 is less than alpha is less than pi/2 at an initial speed of vₒ. Parametric equations for its path can be shown to be x is equal to vₒt cosine alpha, y equals to vₒt sine alpha minus gt² divided by 2 with t representing time. The first part is to eliminate the parameter t and find the value of t when the projectile hits the ground. Right, so we know when the projectile hits the ground, since it's launched from the ground level, right, so we know it's launched from this point, 0, 0, the origin. It travels in a parabolic path, and then it winds up on the ground level at some point. All right, so we have to find the t value when that projectile hits the ground, when it's back on the ground level. Vertical position of the projectile is accounted for by the y values, right? So we know the ground level is represented by when the y value is 0. We're going to isolate the t in this equation and write it in terms of x, the initial speed, and the cosine of alpha, right? So basically, if x is equal to vₒt cosine alpha, then we know t can be solved for by basically dividing both sides by the vₒ cosine alpha. So now what we're going to do, we're going to plug this t value into the y equation. So what we get as a result is what? We're going to get vₒ t, instead of t, we're going to put x divided by vₒ cosine alpha. Then there's a sine alpha on the top. And then minus g, and then the t squared, right? So we have to square this whole thing because the t is being squared, right? So we're going to have to square x, we're going to have to square the initial speed, and we're going to have to square this cosine of alpha as well. And then divided by 2, so if we divide this thing by 2, basically 2 happens to be in the denominator. All right, so now we should cancel that one out. We should also note that sine over cosine is tangent, right? So y can be expressed even simpler as x tangent alpha minus gx squared over 2 initial speed squared cosine squared alpha. What we did here, we just eliminated the parameter t, but now we need to use again this equation with the parameter t, because we're going to set the y equal to 0 because we want to find the value of t when that happens. So what we're going to do now, we're going to multiply both sides by 2. So what happens as a result, the 0 stays on the left side, and we're going to have what? We're going to have 2 vₒ, t sine alpha minus gt squared. Leave the 0 on the left side, but we can factor out the t because it's on both terms here. And inside we're going to have 2 vₒ sine alpha minus gt. T is equal to 0, and we know that's true because at the time of launch, t is equal to 0. Right? We know that it starts from the origin, like we said before. That's when the parameter is equal to 0. However, there's another instance, and that instance is when we have 2 vₒ sine alpha minus gt, and that should be set to 0, right? According to the zero product rule. All right, so that means t, if you divide both sides by g, is going to be basically 2 vₒ sine alpha divided by g. So it says now, sketch the path of the projectile for the case when alpha is pi/6, initial speed is 32 feet per second, and the g, the gravity acceleration component, 32 feet per second squared. Right, so we know t is in seconds, right, based on that. The time is in seconds, right? So you know, based on that the feet cancel out and the second cancel out on the top, but the second on the bottom remains. All right, but that's the denominator of the denominator, right? So the second goes to the top, and that makes sense with the t value because t is in seconds. All right, so notice also that the 32's cancel out, And sine of pi over 6 is 1/2, right? So we get 1/2 times 1/2, 2 times 1/2, which is 1. So the time at which the projectile hits the ground will be 1 second. And that's helpful to us because that 1 second can tell us the x and and the y values that will determine the path of the projectile, right? We're going to draw a parabola using the fact that we have 1 second as the time of it hitting the ground again. Now let's find t is equal to 1. So x will be what? X will be 32, the initial speed, time is 1, cosine of pi over 6. All right, so that basically gives you 32 cosine pi over 6, the radical 3 over 2, so 32 radical 3 over 2. So that's when the projectile hits the ground, right? Because the t is equal to 1. So let's go ahead and label that in. So we know that's the point of launch. And 27.7 feet, that's 25, 26, 27, almost 28. So I would say like here, that's the point. That's the horizontal distance at which the projectile will hit the ground. Since this projectile path is symmetric with respect to line of symmetry, going as a vertical line going through the top maximum height of this projectile, we know it takes exactly half of the time it takes for the projectile to hit the ground to achieve the maximum height, right? So half of 1 is exactly going to be 1/2, right? So let's find the x value there, just to see where that is, and then we're going to find the y value to find the max value. All right, so that's going to be what? That's going to be 16 cosine pi over 6 is still the same, so radical 3 over 2, so that's exactly half of this distance, right? So you could actually just, as a shortcut, you could have just divided this by 2 instead of plugging it in, because you know half of this distance is exactly where the line of symmetry will cross the x-axis, right? So this is about 13.85. All right, so now let's find the y value. That's going to be 16 times 1/2 sine pi over 6. All right, so I'm just going to solve that in. So that's going to be 8 minus, and that's going to be 8, right? 32 divided by 8 is 4. So that's going to be 4 feet. So exactly 4 is going to be the maximum height. All right, so 4. So let's find 13.85. That's about here. So 4 would be right here. The graph is symmetric with respect to this line. All right, so that symmetric line helps us find the t is equal to 1/4. All right, so t is equal to 1/4 will be the same as the t is equal to 3/4. All right, so basically quarter of the time it takes for the projectile to hit the ground will be the same height as the 3/4 of the time that it takes for the projectile to hit the ground because of symmetry. So that's 8 radical 3 over 2, so 4 radical 3, right? 4 radical 3, and let's find the y there. So when t is equal to 3/4, you can use just add the 6.925 to this value. That will be 20.775 feet. All right, so that's the x distance. Notice that the y is equal to 3 feet there because of symmetry. 20.775. That's about here. So I would say like right here. All right, you successfully answered this question fully. I hope you enjoyed this tutorial. Thanks for watching. See you in the next video.